Okay, let's start again once. We will continue the last session where we have continued the index property. We have studied till the fine grained analysis and its aspect and Stokes law. In today's session, we will study the sedimentation analysis in detail. So we are going to study sedimentation analysis. So as I have said, this is made for fine grained soils, and this is sedimentation analysis is a method for finding percentage finer. Remember, the objective is to find percentage finer till now. Okay, we have to find percentage finer than a particular size. D is dia of solid. So fine grained soil means these whose size, such soil in which the soil solid having size lesser than 75 micron. Okay, and under this category there are two soils, namely silt and clay. These are the two type of soil for which we have to make sedimentation analysis to find out the percentage finer corresponding to a particular diameter of soil solid. So what is the procedure? As we have also seen, the entire sedimentation analysis process is based on theory of Stokes law. Yes or not? We have seen it, and we have also derived Stokes law in the previous section. Stokes law, and we have also seen the limitations of Stokes law in sedimentation analysis exclusively. So what is the general procedure of sedimentation analysis? It is of two process, it is of two type, in two ways. It can be done by two ways. The first is pipette method. I think everyone seen one pipette in his life during the +2 studies in chemistry lab, when we used to fill out chemicals from a flask using pipette. This is the same pipette. Okay, this is the same pipette that we have used in our chemistry lab. Now second is hydrometer. This is new to us, so we will study both in detail. Hydrometer. But prior to going over these two methods in detail, we will try to understand the general procedure of sedimentation analysis. So procedure of sedimentation analysis. What is the general procedure? So let's start. What we do is we take first we take 12 to 15, not 15, you make it 30. 15 will be too low value, so make it 30 or 15 to 30 grams of soil sample, fine, just please wait. So where we are, 12 to 30 grams of fine soil sample, and make suspension using water. Okay, the fluid which we use here is water. So There are two volumes of suspension. First is 500 ml and second volume is 1000 ml. So this 500 volume suspension is used in case of pipette method. Okay, and a suspension of 1000 ml is prepared for hydrometer. Hydrometer method. Then after, the second step is, then after certain observations are made at different time interval intervals to find what? Percentage finer than a corresponding size. To find, this is the aim, to find percentage finer than a corresponding size D. So, and one more thing, prior to making observations, what we need to do, we need to stir the suspension which we have prepared, okay, and allow the grains, solid grains to settle. Okay, prior to making observation, we stir the suspension prepared and allow the solid grains to settle in sedimentation. Sedimentation is basically the settling process of settling. We will come across this term in detail while we will study the primary settling tank and secondary settling tank or grid chamber in environmental engineering section. So in sedimentation, jar used for analysis. Okay, so now there are some treatment given to the soil sample which are used. Okay, there are two kinds of treatment. So one treatment is post treatment. Sorry, the order will go wrong. It will be better to write. The first treatment given to soil is pre-treatment. Pre-treatment. Pre-treatment for soil sample. That is before making suspension. Prior to making suspension, we have to give pre-treatment before making suspension itself. Suspension. Now the second one is post treatment. After preparing suspension, post treatment. What are the objectives behind pre treatment and post treatment? We will come across it in a very short time. Post treatment for suspension, okay, prepared. Now what is this pre treatment and why it is given? Pre treatment, pre treatment. The objective behind this is objective. If the sample of fine soil, it will be good to write fine soil having some percentage of organics and gypsum compounds, then under such situation it becomes necessary to remove the impurity from sample in order to make correct experiment. So why we need to remove organics? Because they will function as impure material in the sample and they will prove to be a erroneous factor, okay, a ill factor in case of settling of the sample. Means I have already illustrated that the sedimentation process entirely based on Stokes law, and Stokes law is valid for type 1 settling or discrete particle settling. So if guess or think in mind that if there is organics and gypsum compounds, and as you know gypsum compound is an inorganic, and it will obviously it will have higher density or higher mass gravity than the soil sample or original soil sample, then what will happen? So there will be some changes in actual settling velocity of the soil sample, and we will at end of the experiment we will left with the erroneous results. So to avoid this, we will provide pre-treatment to soil sample prior to making suspension. Okay, so how it is done? So we have to remove two basic things. Two things. First, organic removal. Organic removal. For removal of organic from the soil sample, what we do? Organics, we tend we find a compound that oxidizes the organics from the soil sample. So the basic is to oxidize. For this, for its removal, oxidizing agent, and which agent is used is H2O2. All are clear with this formula? It is name for hydrogen peroxide or hard water. Sometimes it is also called as hard water. Hydrogen peroxide. Okay, H2O2. H2O2 is used to oxidize the organic content from soil sample. Okay, now we have to remove another thing, and it is gypsum. Gypsum compound removal. How it is achieved is, we will add, the recommendation is to add, to remove gypsum content, we add 0.2 normal, okay, hydrochloric acid HCl solution to the sample. On addition of these two compounds, all impurities get removed from the sample. Okay, then after this treatment we will make suspension. So after this treatment, the sample is used for making suspension. So now it's come post treatment. Guess for what post treatment is? Post treatment, look, as I have said that we are making this analysis, sedimentation analysis, to find percentage finer than a particular diameter of soil, and here we are using fine grained soil sample. So as the settling will continue in sedimentation jar, then obviously you have heard about a term, that flock formation, flocculation. So here in this case also there are flock formation, that the fine soil particle aggregate with each other, they form flock. So to deflock them, to such that the settling is in accordance with Stokes law, that is type 1 or discrete particle settling. In order to make that true, we have to add some defloccating agent which will segregate that aggregation. Okay, so we have to disperse them. So it is done to avoid flock formation of fine soil sample in suspension, such that Stokes law governs, that is discrete particle settling. Okay, occur. So to avoid this situation, so solution is, what we do, the code, provision of code is made, which goes follow. According to the code which made this provision is IS 2720. Okay, this is the code which have made this provision according to IS 2720. Till now we have heard about two codes. One code is 460 1962 about sieve. Okay, and this is for this treatment. So according to this code, it recommended that 33 grams of sodium hexa, the same which we have used in case of sand to remove the, to disperse the fineness from the sand grains. Okay, sodium hexa metaphosphate plus 7 grams of sodium carbonate is mixed with 1 liter of water to make solution of it. Okay, by mixing these compounds in a liter of water, we will prepare a solution. Then 25 milliliter of this solution is added to the suspension. Okay, for post treatment of soil, of suspension. So the idea is clear about the pre-treatment and post-treatment, that is sample preparing and conduction of experiment. You should remember the name of codes which are being used here. So now, so let's calculate what is actually added. What is the solid content actually added? So what we have done is, we have prepared total 40 gram of solid is mixed in 1 liter of water. Okay, that is 40 gram in 1000 milliliter. So 1 milliliter contains 40 over 1000 grams of solid of the material, that is sodium hexametaphosphate and sodium carbonate. Hence 25 milliliter of sample solution will contain how much? 40 over 1000 multiplied over 25 ml. Okay, this and on solving this we get 1 gram. So basically 1 gram of solid of NaPO4 6 sodium hexametaphosphate plus Na2CO3 sodium carbonate is mixed in the suspension volume. So what is the concentration of this? So concentration of these solids are, let it be m dash over v. What is this? Gram per ml. What is this m dash? It is equal to 1 gram. And what is this volume? V is volume of sedimentation jar. Okay. So this is the concentration of the solution which is required for post treatment is in the sedimentation suspension volume of the actual sample. Okay. So here we completed the method, the procedure, the basic idea behind the sedimentation process. Now let's start with the very basic method, first method of sedimentation analysis, pipette method. Actually we will look into pipette method. It will go somewhat lengthy in the next lecture section of this. Okay. Well, thank you for observing.